Hello again, pirates. Welcome back to Lopezlandia. Today's section is going to be 2.7, polynomial inequalities. Make sure you have your notebook out, pen, pencil, something with color. We're going to do a little bit of graphing, but just like a number line or an x-axis. And have your calculator out too. Objectives. Students will learn how to solve polynomial and rational inequalities. Find the domain of a function. All right, so the stuff that I have in blue, aqua looking color, make sure you copy this down, please. A polynomial inequality is any inequality that can be put into one of these forms. All right, so we're going to have polynomials where we have the polynomial is going to be less than 0, or it's going to be greater than 0, or less than or equal to 0, or greater than or equal to 0. So notice that the 0 is going to be on the other side of the inequality, okay? And just in case you don't recall what polynomials look like, here you go. So you have your monomial, your binomial, your trinomial, and anything more than 3 terms, boop, 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 will be a polynomial, all right? If you feel like you need to copy that part down, that's fine. If you don't, that's fine too. But make sure you have the stuff in like greenish, aqua looking color copy down. All right, let's start our first example, okay? So we have x squared is less than or equal to 9. If we quickly look back at the aqua part, notice that we're supposed to have the 0 on one side of the inequality. We don't have that yet. So let's get it there first, okay? So I would have to subtract the 9 from each side and move it over, correct? So when I do that, I should be left with x squared minus 9 is less than or equal to 0. We want to solve for x, find our x-intercepts, okay? That's what you want to do. So there's a couple ways you could work on this one. You could factor it out. You could pop it into quadratic formula, do completing the square, whatever your little heart desires, okay? Here, I noticed that it's x squared minus 9, so I noticed that it's differences of 2 perfect squares. So for this one, I'm able to factor this out quickly. So differences of 2 perfect squares would look something like this. We know that x squared is a perfect square. That's what we have, x and x. 9 is a perfect square, so that should be 3 and 3, right? Because we have our negative here. One should be positive. The other one has to be a negative, correct? So we have it as an inequality. So now we have our factors. X plus 3 times x minus 3 is less than or equal to 0. So I want to find my critical points. So I'm actually going to turn it into an equation and solve for x. So we're going to solve for x. Critical points. Our critical points are going to go on our little sign table or sign chart. Set each of your factors equal to 0 and solve for x, all right? And what do we get? X should be a negative 3 here because we subtracted, and x should be a positive 3 because we added on that side. So my critical points now will be x equals a minus 3 and x equals a positive 3. At this point, we're going to start creating a sign chart. Stay tuned. It's going to be on the next slide. Make sure you have everything copied down, please. So as a reminder, that's what our problem was. X squared is less than or equal to 9. So we changed it to that because we have to have the 0 on one side of the inequality. All right. So let's get ready to write our little sign chart. So when we're doing our sign chart, what we're doing here is that we're going to put the factors. That x plus 3 is coming from this being factored out. And this is what our sign chart's going to look like. The minus 3 is coming from here. Remember when we solved for x, and then that minus 3, right? X minus 3 equals 0 was that positive 3. That's where that's coming out, okay? So also at this point, you want to look at the inequality. We have less than or equal to. So you should be asking yourself, am I going to have a solid or a, sorry, full circle or open circle? Closed circle or open circle? That's what you should be asking yourself. You have the line underneath, so you should say that you're going to have closed circles for both. Okay. So we said this was going to be a sign chart. In order for me to complete this sign chart, I am gonna figure out what signs I'm gonna put here, and I'll tell you what I mean. So again, this is representing my beautiful x-axis, and here goes a -3. So over here, we would have anything that's negative, right? -4, -5, -10, -100, right? Etc., right? So I'm gonna pick, or I can pick, any number that's over here that's less than a -3. So -4, I could pick -5, etc. As long as it's over here. I'm going to go with a -4. So again, I could pick any number that would satisfy this part right here that would be less than a -3. And what I'm going to do with this -4 is I'm going to put it into each of these factors and see what we get. So again, I'm starting off with a -4 and substituting into each of the factors. So this will be a -4 plus 3. Well, when I put in my crusty dusty little calculator, I actually get a -1, right? But what's important here is not necessarily the 1, but the negative itself. I would get a negative value. So here I would put a negative. Do the same thing over here. We're substituting the -4 and putting it in this factor down here. So -4 minus 3, that would give us a -7, correct? Again, the 7's not important. The fact that we got a negative number is what's important here. Oh, snap. So make sure you put a negative here. Showed you too much. My bad. All right. The next thing we're going to do is we're going to figure out numbers that are in between the -3 and the +3. So it could be anything that lies in between those two numbers. I'm going to go with a beautiful 0. All right. And I'm going to substitute into each of these factors. So let me cross that over or box it up. So now I'm going with 0. And this is going to be 0 plus 3. What do we get here? That's a +3. So because it's positive, that's what I care, not necessarily that it's 3. So I'm going to put a plus there. And then do it again for the bottom factor. So we're going to put 0 minus 3. That's going to be a -3. So the thing I care about here is the fact that it came out negative. So I'm going to put a negative down there. Are we okay? Now, for the next part over here, I'm looking at the +3. Now I want numbers that are going to be greater than 3. So numbers that are greater than 3 would be 4, 5, 6, 7, 8, 9, etc., right? So same deal. You're going to pick whatever you want as long as it's greater than 3. And we're doing the exact same thing all over again. I'm going to go with a +4 this time. So putting in a +4, this would be 4 plus 3, right? That would be 7. So the fact that it is a positive is what I care for. Same deal with the bottom. We have 4 minus 3. Again, that's going to be a +1. So I'm going to put a positive right here. The fact that it's positive. So let's finish that up. All right. Now, for down here, what you're going to do is multiply your sign. So a negative times a negative would give you a beautiful positive, right? Positive times a negative would be a negative, right? Positive, positive, positive. Cool, cool, cool. But wait, there's still more, guys. Ready, ready, ready? These are inequalities. So we still need to finish this up. The thing I'm going to focus now is on the inequality. I'm going to go back to the inequality. Now it says the polynomial. Where is a polynomial less than or equal to 0? So you're thinking, what are those numbers that are less than 0? Is it going to be positives or negatives? In this case, you would say, negatives, hello. So looking at your sign chart, where did we get negative numbers? It would be right here. If we were to pick numbers that are between the -3 and the 3, that's where we would end up with negative values there. Okay, so that's where we're going to connect our point. This is our solution here. Our solution is this right here. Now, I'm going to write it in set builder notation as well. So we're going to have the set all x such that -3 is less than or equal to x, and that's going to be less than or equal to 3. Let's try another one, little ones. Again, with this, you want to make sure that you have 0 on one side of the inequality. That means it's 15. We got to move it over. How? By subtracting it. So when we subtract it, we end up with 2x squared plus x minus 15 is greater than 0. Just like before, you want this in factored form. So I'm going to factor it out. Again, if you're able to factor it, do it. If you like completing the square, you could do it that way. Or quadratic formula. But try to factor it first, okay? So I'm going to go ahead and factor this out. I'm going to use bottoms up just in case you've forgotten. Here we go. On top, I'm going to have a times c, bring down the b. So over here, that's a -30 when I multiply those two, right? And then my b value, that's uno. Good to go. So now we're thinking of numbers that'll multiply to 30 and add or subtract to the 1, right? So the thing that comes into mind for me would be the 5 and the 6. So I'm going to go with 5 over here. I'm going to go with 6. It's negative here, so one of them has to be positive. The other one has to be a negative. So I'm going to go with -5. Cool? But wait, we need to do bottoms up. So remember, you're always dividing by your a value, right? So what was my a? My a value is this beautiful 2 that I have here. So dividing by 2, dividing by 2. Setting this up in factored form. It would look like this. X minus 5 over 2 times x plus 6 over 2. But wait, we still have more. Check to see if you're able to simplify. In this case, you can't, so bottoms up. So what do I mean by that? This 2 is going to move over here. Just in case you forgot, a little refresher. And then this simplifies, yes, in English. Yeah. Cool. And at this point, this and that, I just included the inequality symbol, same deal. I got to look for these critical values now. So just like before, you're going to set each one equal to 0 and solve, right? So we have 2x minus 5 is equal to 0. Add the 5 to each side. So we have 2x equals 5. Divide by 2. Right? For this one, we have x plus 3 equals 0. And then x is a minus 3 here, right? So my critical points will be at x equals 5 over 2 and x equals a -3. So this is what we had before. Apparently, I didn't change the order, but you saw it in my red pen. Let's carry on. We're not done. We still need to create our lovely, lovely, lovely sign chart. So again, that was our original problem. And for my sign chart, I'm going to write the factors again, and I'm also going to include the critical points. So this is what it's going to look like. Make sure you have it down, okay? Now, as far as filled circle or open circle, you're going to ask yourself, or you're going to look actually at the inequality. We have greater than only, no equal to. So my circle should be open for each one. We're okay there? And we're going to do the exact same process we did earlier. So again, I'm looking at that -3. I'm looking for values that are going to be less than -3. So it could be absolutely anything as long as it's less than a -3. So for these one, we're going to go with a -4 again, just because. I know, I'm using it again. So do it now. This is going to be a -8, right? A -8 minus 5. The fact that it's a negative is what matters here for me, okay? So we're going to put in a negative in there. Do it for the bottom. So -4 plus 3, that's going to be a negative, right? So make sure you have that there as well. In here, in this interval right here with the -3 and the 5/2, we want a number that's going to be in between those two. So make it easy on yourself. I went with 0 again, or I'm going to go with 0 again. And you're substituting into the factors in here. So this will be 2 times 0 minus 5. That's a -5, right? The fact that it's minus, that's what I care for. And then 0 plus 3, that's a positive. So a plus will go right in there. Same thing here. We're looking for numbers that are going to be greater than 5/2. 5/2, that's 2.5, right? So I'm going to go with a 3. So I'm substituting a 3 in here. So substituting a 3, this would be 2 times 3 and minus a 5. So that's 6 minus 5, right? That's a positive. So I need to have a positive there. And then 3 plus 3, that should be a 6. So again, the fact that it's positive, that's what I care for. All right. I went ahead. So again, you're going to be multiplying these signs. Negative gives you a positive. Positive should be giving you a negative. Positive, that's a positive there. Now we're looking for our solution so we can finish graphing this thing. We are looking for, let me rewrite this part right here. We should have been the 2x squared plus the x minus the 15, right, is less than 0. So we're looking at the inequality. So here we're looking at where is that polynomial going to be greater than 0? So again, we're talking about values that are going to be greater than 0. We should be thinking about positive. So if we look at our little sign chart here, this is where I end up with in positive territory. Here, I end up in positive territory as well. So this would be my graph right there. Does that make sense? Now, I'm also going to write this in set builder notation. So in set builder notation, we're going to have the set of all x's such that x is less than a -3 or x is greater than 5/2. Now you know.